Let us discuss about an AC circuit which contains only an inductor. How the circuit is? See, the circuit will look something like this. We have an inductive coil to which a AC source is connected. Let us say the value of self induction is L, and here the source is given as E is equal to E naught sine of omega t. This is what is the AC source. Now, we know that E is L di by dt in an inductor. The induced EMF can be written as E is L di by dt. Therefore, what we can say, E is E naught sine of omega t, this is L di by dt. Our aim is what? To find the expression for the current. So, therefore, regroup the term. Therefore, di is equal to E naught by L sine of omega t dt. So, therefore, I will be what? Integration of di. So, integrate this expression, that is E naught by L integration of sine of omega t dt. So, if we integrate this expression, what we get? Therefore, I is equal to E naught by L into minus of cos of omega t by omega. So, the expression for the current we arrived at. So, therefore, I is equal to minus of E naught by omega L cos of omega t. This is the expression for the current. Now, we can transform this equation also, or I is equal to, I can write it as E naught by omega L sine of omega t minus pi by 2. Apply sine of C minus D, you will get the same equation minus of cos omega t here. So, this term E naught by omega L can be written as I naught because the maximum value of sine function is plus 1. Therefore, this can be written as I naught. So, therefore, I we write it as I naught sine of omega t minus pi by 2. This is the expression for the current that we get. So, what we can say here? What we observe is, first of all, the expression for the voltage was E is E naught sin omega t. For the current we got I naught sin omega t minus pi by 2, which means there is a phase difference of 90 degree. So, the question is lag or lead. So, here we find it is minus pi by 2. Therefore, current lags EMF in L only circuit by 90 degree. So, that is exactly what we can say. So, if I compare with the expression for the voltage, this is what we can conclude. Compulsorily, this has to be remembered that in an L only circuit, the current lags EMF by 90 degree. Now, one more point we have to observe. We wrote I naught as E naught by omega L. Now, E naught is nothing but volt. This term has to be ohms. Then only current I naught will be in amperes. This means omega into L is behaving as resistance, because you are measuring it in ohms. This term omega into L is behaving as resistance. This is known as inductive reactance. So, in AC circuit, the resistance offered by an inductor, what is inductive reactance? XL. This is omega L. This is known as inductive reactance. So, what is inductive reactance? The word resistance is reserved for the DC circuits. Therefore, in order to distinguish resistance in an AC, the word reactance has been used. Reactance is for AC circuits. Inductive reactance, so it is the resistance due to an inductor. So, what is inductive reactance? Inductive reactance is the resistance offered by inductor to AC. This is called inductive reactance. Now, the question arises, what if we place it in a DC? In a DC circuit, F is 0, therefore, omega will be 0, therefore, XL will be 0. So, inductive reactance in a DC circuit is 0. So, inductor will be of no use in a DC circuit, while in an AC circuit it is capable of blocking the current. That is why inductor behaves as a resistance in an AC circuit, and because of this reason, choke coils, which is a trade name for inductors, is used in the tube lights in order to block the AC and bring down the operating voltage. Now, what we have is power consumption. Because we have seen what exactly is the expression for the current, now we are perfect in a position to find out the power consumption. Power consumption by L. Now, again instantaneous power. The instantaneous power P is E into I. Now, this E is what? E naught sine of omega t, and I we got as minus I naught cos of omega t. So, this can be written as minus of E naught I naught into sine of omega t and cos of omega t. This can be further written simplified as minus of E naught I naught by 2, and this becomes sine of 2 omega t. This is our instantaneous power. So, therefore, average power will be what? Therefore, average power P average, this is same thing over one complete cycle. So, P dt from 0 to t upon dt from 0 to t. So, what we get this as? Minus of E naught I naught by 2 t integration of sine of 2 omega t dt. Now, simple logic, sine of 2 omega t will also be a sine wave, and we are integrating over one complete cycle 0 to t. We know that average value of a sine function over one complete cycle is 0. Therefore, average power consumption is 0. Very important. In an ideal inductor, the average power consumed in its operation is 0. That is the best part of inductor. See, it is not consuming any power. In spite of that, it is able to block AC, and it is behaving as a resistance. That is the feature of an inductor.